Alrighty. So this is where we're going today. We're going to talk about a resource that we have developed called Ergo Insights, and it's all about helping you work through any manual material handling challenges when it comes to work design. My name is Nathan Birch. I am a registered kinesiologist and a Canadian certified professional ergonomist, and I've been with WSPS for about 6 years, and in the ergo world for longer than I care to mention, but more than 15 years, we'll say that. And we'll start it off here with a poll. So we'll get a poll launched here. How much weight is too much to lift? What do you guys think? Curious on your thoughts here. This is one of the questions we get asked all the time as ergonomists. Do you think it's 50 kilograms or 30, maybe 20, 10, or is it something else? Let you guys submit your answers there and then we'll have a look and see. See the answers flying in here. Give you another few seconds to answer that one. All right, perfect. So I think most of you caught on that, this is really a trick question. So many of you saying other as far as your answer to that. And that's really, I guess, the right answer in this situation, right? Because there's a lot of things that go into how much is too much, right? It's impossible to give a blanket statement on that. But, some of you saying 30 might be too much and 50 might be too much, but most of you not falling for the trick question. So good job, everyone. But that's really part of the issue here. And where we want to go with today is to give you a resource, give you something that can help you answer this question in a relatively short period of time. So next poll, do you currently experience challenges related to understanding when manual material handling tasks are a problem? Yes, no, or I count on my workers to tell me. Suppose you can answer more than one, but you only get one option for this. Give you a few seconds there. Getting a mixture of responses here, but definitely the majority of you saying, yes, this is a problem. So good, you're in the right place. That's definitely what we're here to talk about. Some of you saying, no, not a problem. Maybe you've got some knowledge or some experience on dealing with this, and I may ask you to share your contact so I can help, or so you can help me maybe. I count on my workers to tell me, many of you saying that as well. So we hear that a lot as well, right? It's not a problem until I know it's a problem or I hear it's a problem from our workers, right? But many of you saying yes. So a common issue, which we're here to kind of help with. All right, getting a little more complex with our poll question here. If a worker lifts 15.7 kilogram ingredient bags twice per minute, lifting between a height range of 33 to 140 centimeters with the horizontal reach of 34 centimeters and 25 degrees of asymmetry, is it acceptable? How's that for a question? Really curious on what everyone's going to say here. Is it yes, no, maybe, question mark? Or you don't have the slightest clue? Just a big number dump on you guys here. Some of you've got the answer though, you think, eh? See some yeses, see some nos, definitely some maybes. Most of you saying, I don't have the slightest clue, which is, I appreciate all the honesty there. That's perfect. So really, I mean, there's no, there is a right answer here, but to get this, you really need, it's kind of complex, right? I'm throwing a lot of numbers at you. And so how do you actually know this is a problem unless you have directly in front of you right now an ergonomic assessment tool that will help you navigate through that and get the right answer here, right? Yeah, Tim, I need a free body diagram to figure it out. Exactly. So, right, not everybody can do this. It can be kind of complex. And again, that's sort of what we're here to help navigate through. Appreciate that comment, Tim. But really, the actual answer is, if we used, and I just put this through the Liberty Mutual tables, giving us a maximum acceptable limit of 11.5 kilograms. considering, we want most people to be able to do this job. Only 31% of the female population would be able to perform this according to kind of strength data in this tool. So the answer is actually no to this question. We'll get into that more. You don't have to have a degree to kind of figure this stuff out, right? Sometimes it feels like you do. So this is where we're going. We're going to talk about approaches to manual material handling task design and what that looks like, what some common approaches are, might be some familiar territory as far as how you make decisions in your facility. We'll talk about kind of the MSD problem and why we need to continue to kind of deal with it. And introducing our tool, the Ergo Insights, as the kind of meat and potatoes of the session here. And then we'll definitely be using it as we get into some practical application and examples to go through so that you sort of understand how to use the resource. All right. So when it comes to different approaches of manual material handling task design, a lot of companies, it's, everything is kind of bottom line driven, right? It's just the way of the world. And so production, cost, quality, these are kind of common metrics or common ways of kind of driving decision making when it comes to manual material handling. And so maybe we start with that finished product and we kind of work our way backwards to kind of get what we need, right? We need these materials, we need it in this timeline, and we need to get it the cheapest way as possible, right? Of course, we all sort of operate that way in our lives. So, we order maybe bulk or large quantities. We maximize that trailer load and we have pallets of items and product that's stacked from floor all the way up to the top of that trailer, right? And then, we think about our storage inside our facility. Once it gets there as well, we have to maximize that floor or storage space from shelving, racking, staging areas, right? All these areas need to be kind of optimized and maximized. Instead of maybe going horizontally, we need to kind of look at vertically. And there's some ergonomic considerations and issues with that, right? And often when we get to the human in these situations and when they start kind of manipulating and handling things, it often turns into a double handling or a triple handling situation. And we end up kind of in the situation where we're handling things more than maybe what we should or need to, but we're also kind of limited, right? By the time the human is considered, we're limited in how that material can be moved, can be shifted around, handled, because we made these decisions, looking at productivity, cost, quality, and didn't really consider necessarily the human. Now, this is not always the case, but often this is what happens, right? It's an afterthought. So maybe, someone who's designing work, for example, they may approach their decision making based on their own capabilities. So not to pick on engineers, but say an engineer is designing a work cell or someone in production is designing a work process, they may design it based on their own capabilities. So, I can lift this item. And so, people should be able to do it, should be fine. Or this workstation height is good for me, so it should work for everyone. And it's surprising how often we actually hear that that's how decisions are made, but it does happen, right? Or maybe you're dictating, like I said before, as far as the supplier, the packaging, the transportation. Those decisions dictate how you handle and how the human interacts with things. Or maybe you've chosen to have a blanket weight limit. So we don't lift over 25 pounds or 30 pounds or 50 pounds, whatever the weight limit you decide as a company is, right? And so, maybe that's how you decide to handle it. But, someone who can lift 50 pounds may have no problem with that, but another person may. And we start throwing in all the considerations as far as frequency, size of the object, all the other things that are handled in a day, whether it's carried, like all these sorts of manual tasks, and it starts to get really complicated as far as, okay, well, is it acceptable or not? So a weight limit isn't necessarily always a good way to go. Or maybe you're making decisions based on injuries or incidents that have happened, right? Someone gets injured, where in the past, this hurt somebody, so we're going to, design based on that parameter. Or maybe you're a little ahead of things and you sort of incorporate ergonomics a little bit, sooner, and you have, you complete assessments for internally for, your processes or your work during kind of that design phase, which is fantastic if you do. Or maybe you'll rely on external expertise, such as myself as an ergonomist, right, to assess tasks, to come in, to look at things, or maybe even have your own company ergonomic design guidelines, right? Holding your company to a standard of internal standard of guidelines when it comes to work design, equipment design, tool design. So different approaches that we can take here, and some better than others, right? And these are great. These are, as ergonomists, we're like, yeah, this is what we need. This is what we want to see people do, and all the more power to you if you're looking to get into going in this direction. But a lot of companies just don't have those resources or the time to do it when it comes to thinking about work and designing work. So another poll for you here. How does your company approach manual material handling task design? And I hope I don't have to say that too many times today, because that's a tongue twister. How do you approach it? So you can select multiple answers on this one, not just one. So what do you think? Do you make decisions based on the capabilities of the task designer? Supplier, customer packaging, and storage needs, are those the dictators? You implement a weight restriction, react to injuries or incidents that happen, so more reactive approach. Do you rely on your workers to tell you if there's a problem? Or do you complete ergo assessments during the design phase? Or do you even have your own ergonomic design guidelines? Give you a few moments to fill that out. Answers still coming in here. Seeing a good mixed response here. Highest response here, we rely on our workers to tell us if there's a problem. So very common, right? We don't know it's an issue unless someone tells us. Again, it's kind of a reactive approach, unfortunately, right? I understand why you do it, because you don't know what you don't know, right? Some people saying we complete ergonomic assessments during design. A couple saying they even have those design guidelines, which is amazing. And as expected as well, decisions being made on the task based on the task designer capabilities. Yep, many of you saying that as well, or dictated by packaging, storage, customer, or supplier, I should say. Good mixed response here. So lots of different kind of approaches when it comes to this, but all the more kind of showing the need for assistance in this area. So this really points to a bigger problem, and a problem that isn't going away and hasn't gone away for decades, really, when we look at it. And we look at the impact of MSDs in Ontario. This is from msdprevention.com, and definitely recommend going to that website, checking out all the resources if you're not familiar with it. There's lots there, and you'll find this graphic there as well. But really, that 35% of all claims in Ontario, right, are MSDs. And that has really stayed the same, definitely for the past 10 years, if not decades, right here, between that 30 to 40% hovering in that. And it really isn't changing much, unfortunately. Our awareness of ergonomics has improved. Companies are kind of relying on ergonomics more, but it's not really making its way to those more proactive realms as far as design, being more proactive before things even get to the human in that sense, right? But there's a lot of costs associated with it. We have our direct costs of WSIB premiums, any prescriptions, replacing a retraining worker if they're off, right? That worker needs to be replaced, and then training, and then that worker who's off may need to be retrained into something else. If you home care, fines from the ministry, and in those really terrible cases, surgeries may be part of it as well. So direct costs can be fairly significant. If we look at the total cost of all sprains and strains, 2023, it's 266 million. So it's not a small chunk of change. And that's just sprains and strains. There are other categories that could fall under the umbrella of MSDs, but sprains and strains are the bigger one. And so it is a fair chunk of change that we really can't ignore. And really, we're just talking about direct costs here, right? So if we look at indirect costs, a little bit more difficult to measure, but these are things that really do impact the bottom line and impact the company overall, right? People who are getting injured, people who are hurting, they're going to be more stressed, which is going to affect mental health, and we all know that there is a lot of cost to a company associated with that. Reduced productivity, right? People who are hurting are not going to be working as fast, as hard. Their motivation is going to tank, right? Their quality is going to suffer as well because they're not present. They're distracted by their injury, by their pain. And if there's certain quality checks, for example, that are difficult to do, right? You may have to kind of crane your neck or reach or bend. What's going to be the first quality check that gets missed? The one that's uncomfortable, right? They're going to get skipped. Of course, many of you likely familiar with the administrative burden of these injuries as well, as far as dealing with WSIB, a return to work specialist, back and forth between them and the worker, their supervisor, paperwork, all the time associated with that is a significant administrative burden. And of course, it leads to turnover and morale, right? If people are getting injured, they feel like they're not able to recover, or even their peers noticing that many people are getting injured, the company morale is going to suffer. People are going to leave. They're not going to stay. And that trickles out to the overall company reputation, right? People's families talk to their families, to their friends, and it kind of trickles out into the community. So, lots of more we could say about indirect costs, but keeping it simple here today, but there is a significant cost there, which we can't ignore. If we try to put some harder numbers to this, if we look at direct costs from an MSD, and this would be like kind of non-lost time for the most part here, it's average about $6,500, but I'm rounding up quite a bit here for easy math. So $10,000 we'll say for an MSD, and the indirect costs are usually anywhere from 2 to 7 times. There's varying numbers out there that I've seen and heard, and so I meet in the middle here. We'll use 4. So that equals $40,000 for indirect, with a total of direct plus indirect of $50,000. And this is obviously just an estimate, but you can see how, what's kind of surface level direct costs and all the, that's the tip of the iceberg, like below sea level. The rest of that iceberg, those indirect costs can be significant. If we look at a lost time injury, right, significantly more. I've seen the number 60,000 thrown around quite a bit as far as a potential average cost of a lost time MSD. And if we look at that and multiply it by 4 for our indirect costs, you're at 240,000 for a total of 300,000. So you can see how this quickly snowballs. Now, I do like to bring it back to the humanity. I've talked a lot about numbers as far as the problem and cost to the company, but what about the worker, right? Many of you health and safety professionals, right? You're in the business of helping people, and so we really care about these workers, myself included. And so, bringing it back to the humanity is really important, right? There's so many ways that an injury can impact a worker, right? I don't know about you, but I do not enjoy the thought of working for 85% of my salary, and that that's what, when people are off at WSIB, that's kind of what they're looking at, and so there's a significant effect to that. If you got a back injury, you might not be able to handle going on a plane ride or a long drive for vacation, and so then you're affected that way from a mental health, from a work-life balance standpoint. Maybe you can't do your hobbies. Your sleep is likely going to be affected if you got an MSD, and what do all those things do to your mood, your motivation, depression, anxiety, all these sorts of things, right? And then what about the family unit, right? You can no longer assist with your children as far as childcare, getting them to and from daycare or school, or helping with those regular child duties. If you have to lift your kid, maybe you can't all of a sudden, right? And that's all on one spouse now. Same with the cooking, the cleaning, right? The laundry, all these sorts of household duties that you might be sort of unable to help with, and the associated stress with that. So it really kind of snowballs and can be an issue. And thanks, Don, for putting that cost calculator in there, which is a great resource from msdprevention.com as well. So I've given you some numbers there, but you can use that cost calculator to kind of dive a little bit deeper. So thanks for that, Don. So the problem persists, right? It remains at that 35% of claims, impacts the workplaces, impacts workers and their families. And so it's staying the same. It's hovering on that 30 to 40%. And we really need a different approach to get different results, right? And that's kind of the message here. So approaches to task design here, again, kind of summarizing this first section here. It can be complex. If we're trying to answer these questions as far as how much is too much that I gave you at the start here, we really need to know some information in order to actually, answer that question. So we need to know the frequency. So how often it's done. We need to know, is it a one-handed or a two-handed task? The height. So are we lifting from the floor to shoulder or waist to shoulder? What kind of vertical range are we talking about? And what about reaches? Is it close to the body? Is it far away from the body? And then duration. So how long are we doing it for, right? 2, 4, 8 hours. Demographics. What's the kind of makeup of your workplace? And there are different sort of strength tables or strength data we might use when we look at these things. And so we need to understand our demographics to kind of better gauge that. And we also need to know, are there other things that are being handled? So we're looking at one lift, for example. Are there any other things that are being handled and lifted throughout the day to understand that cumulative exposure and impact? So it can be complex. And these are just some examples here, right? If we're going to assess a lift as an ergonomist, or maybe some of you are familiar, right? There's the NIOSH lifting equation, the Liberty Mutual manual material handling equation, Mital tables, Snook and Serial tables, ACGIH, and ISO has a standard on manual handling as well. So there's many different ways. So you might be asking the question, where do I start? How do I know which one to use? And it can be a little bit challenging. And so we want to help kind of navigate through that. And you don't have to be an ergonomist to start looking at these things, to start understanding how to kind of design properly, or a way that most people can do a task safely. Now, these assessment tools may give you the most accurate results, but again, it can be complex, it can be time consuming. And so really we see a gap, we see a need for something simpler, a simpler kind of preliminary method to look at manual handling tasks to get you started, right? And that's what I want to highlight through today, is this resource is really all about giving you that starting place. It's not the be all end all, it's not an in-depth assessment methodology, but it's somewhere to get you started from a preliminary standpoint. And so that's what this resource is all about. And so we'll get into that now. This is what it looks like, the cover page here, and really what it is. It's that simple approach to material handling task design. And it's designed by us ergonomists for those with minimal ergonomics knowledge. So the idea is, giving you something you can use that you don't need a degree for, that anybody can kind of use and visually look at as a starting place to design these tasks, or to kind of gauge where some of your lifting tasks currently are as far as risk level and that sort of thing. So we have kind of 4 sections to the resource. There's the first section on lifting and lowering, the second section on storage and container zones of comfort and design, a section on carrying, so determining the acceptability of a carry task, and then pushing, pulling, and cart design. So those 4 really capture most manual material handling tasks and kind of design components. So that's why we separated it into those 4. And so we'll get into the format of it now. So again, designed to be simple, right? So easy to understand, kind of quick to use. We have a visual anchor, right? So a graphical representation that you can see on this one for lifting and lowering to give you a visual with measurement references, which you'll see in a moment when we get into the practical component of it. So there'll be some measurement references like shoulder height or knuckle height or eye level, that sort of thing, to help kind of understand what bucket you're in and that sort of thing, as well as color coding. We all like colors and making things look pretty, so we tried to add some color there to help understand as far as, what's good, what's bad, or what's ideal, what's not, that sort of thing. And of course, we want to be practical, so applying this to kind of real working scenarios, and just highlighting again, this is that preliminary evaluation. There are some limitations, assumptions that we make for this tool to make it simple, to make it easy. We have to have some limitations and assumptions in order to, package it like this. So again, it is that preliminary. It doesn't mean you don't need to do a more in-depth assessment, but it's that starting place. All right, so the components of it, we have that visual anchor, and each section has one of these kind of visual pieces to help you see it better and understand it. Detailed measurement references, as I said, and instructions. So again, keeping these instructions fairly simple. So 3 to 4 points as far as walking you through how to use the tool, keeping it simple that way. We have a legend section that helps you understand what are the different colors mean, or the different frequencies and letters, and you'll understand that better in a moment. And then there's a second page to each section. So for lifting and lowering, there's a second page that has your information on assumptions and limitations, what references we used for this document, as well as what assumptions were made and how you need to kind of understand those limitations to use it properly. And we provide some key points. So for this one, lifting and lowering, right, we have, things like keep it close, keep it off the floor, that sort of thing. Some key points as far as lifting and controlling hazards related to lifting. And then the section specifically on different controls. So we provide sort of that guidance on what is green, what is yellow, what is red, but how do you keep it in the green? Providing you with some controls on how to do that. Very kind of general, because every situation is different, but also what happens when you can't keep it in the green. And so provide some other options there as far as working down that hierarchy of controls into maybe more administrative controls, or less sort of engineering and elimination type controls. All right, so we'll get into kind of using it now, and don't worry, you will be provided a link to the tool itself in a moment, but this is where we're going as far as just getting using the tool a little bit here, so you can understand how we might apply it to your working scenarios. I'm not seeing any questions coming through here, so we'll feel free to ask as we go along, but we'll definitely have some question and answer period at the end as well. Okay, so first off, we'll do a lifting task here. And this is the visual anchor, or the visual piece, what you see as far as the kind of main component of the lifting lowering tool. So it's kind of chart format, and you see it's color coded, right? And so if we look at this task, we'll kind of break it down, and then we'll do it kind of piece by piece. So we're lifting a 12 kilogram tote of parts. We start that lift at a shelf height of 20 centimeters, 25 centimeters away from the body, so fairly close. And we end that lift at a storage location of 143 centimeters high, hand height, and 40 centimeters away from the body. So a little bit further away from the body at the end, and a little bit higher at the end of the lift. And we perform this 16 times per day, or 2 times per hour. So asking the question, is this acceptable? And we'll go through it piece by piece now. So the start of that lift, it is that shelf height of 20 centimeters. So it is, if we look at that anchor there, 47 centimeters, that measurement anchor, it is below 47 centimeters, so 20 centimeters. So that's our starting point. It is 25 centimeters away from the body. And I'll grab my laser pointer so we know what we're looking at. So down here, you'll see close, mid, and far. And we are in this close section here. So it's 0 to 34 centimeters is that range. So we'll call that close. And because we are the shelf height, or sorry, the start of the lift is 25 centimeters away from the body, fairly close, then we're into this bucket here, because we are below that 47 centimeters and we're in this close range. So we know we're here, okay? At the end of the lift, we know it's 143 centimeters high. And so we know it's above 125, this kind of cut off here, but it's below 144. So we're in this bucket here because, again, we are in that mid-range. Down here, we see 34 to 49 centimeters. We're in the mid-range, so this middle column here, and it's in this bucket here. So then we look at frequency. So we've determined that we're twice per hour, which brings us into frequency B. And the number that you see beside it, that is your recommended weight limit. So we have 13 kilograms for the end of the lift and 18 kilograms for the start of the lift. And so when we look at this lift from the start to the end, we're going to take that lower number as being our limiting factor. And so we know that that's our recommended weight limit of 13 kilograms. So is it acceptable? The answer is yes, because that 12 kilograms is below the 13. And so again, there's some assumptions or some limitations, assumptions that we sort of have to make this a simple tool to use, but it is, again, that kind of quick and easy. Once you get using it, especially, you kind of get a quick and easy understanding of what those weight limits might be. Okay, we'll do another lifting task. So we got 23 kilogram ingredient bag now, and we're lifting it at a starting height from the pallet height of 15 centimeters, 25 centimeters away from the body, so close again. And we're ending at a hopper location of 120 centimeters high, 30 centimeters away from the body. So fairly close again, but a little bit higher, performing it once per minute. So again, is this acceptable or not? So we look at that start of the lift. Again, we're in this bucket here. And so we know we're kind of in that zone because it's 15 centimeters, right, is the height, 25 centimeters away from the body. So again, we are in this close range and below knee height for the shorter individual. For the end of the lift, it's still close because we're 30 centimeters. So we're in this close range here. We're in this bucket here because it is below 125.5 or shoulder height for the shorter individual because it's 120 centimeters. So you just need a little bit of measurement as far as heights and reaches, and you can use this tool fairly easily. And if we look at that frequency of once per minute, we're in frequency D. And so we have 13 kilograms for the lower and 14 kilograms for the upper. And so that is our limitation there, that 13 kilograms. And we know because of that, the 23 kilograms exceeds that recommended weight limit. And so it is not acceptable for this scenario. I just see a question coming in here. No silly questions. No worries. There are no silly questions. Yeah, so ABC, I think you're asking what ABC means. So if you look at, and you'll see this on the document itself, which you'll get a link to, but this legend here, the frequency legend, that tells you what the A, B, C, D, E, F means. So it corresponds to a frequency. So for example, for this one, D refers to once per minute. And so we know we're in this bucket, for example, and D, the frequency of once per minute is 14 kilogram limitation. So hopefully that helps answer your question. So this one was not acceptable, we had determined. So we don't want to just leave you there. Then we want to look at, right, some control options, and we give some general controls on the second page that you could kind of understand what you might be able to do. So maybe you got to raise the pallet, right? Maybe if we raise the pallet, so we're not in this bottom location, but maybe we're in the yellow or even the green, then maybe we've got a safer situation there, right, where they don't have to bend as much. So reducing that risk. Maybe we can break up the load or reduce the weight. Maybe we can lower the frequency, right? That affects our ability to do something as well, our fatigue levels. Or maybe we got to bring in some mechanical assistance, like a vacuum lift for these ingredient bags or something like that. Or maybe it's a two-person task, depending on how you can handle that safely. Job rotation, again, we're working down the hierarchy of controls. It's not going to reduce the risk, but it might help reduce some of the exposure. And so making sure that, one person isn't lifting 23 kilograms all day once per minute, right? Of course, safe lifting, again, doesn't reduce the risk, but it also does, if we know that we're already in a risky situation with 23 kilograms, but it does help as far as reducing the potential for someone to lift poorly and put themselves at even more risk, right? So safe lifting training can be effective as an administrative control, but again, doesn't get rid of that risk. And of course, supervision, right? If we have a supervisor who is managing and kind of making sure that people are using good lifting technique, they're not working at a pace that's unsafe. We're not extending yourselves beyond, where that person should work. Then we're going to make a difference there. And just looking at some more questions coming in here. Yeah, Tim, good. See, giving this to your grounds crew, excellent. So, is there frequencies between 1 per minute and 12 times per hour? Yeah. So. I see. Yeah, so we're limited, right? If I put every single possible frequency into this tool, it would be a very complex, visually difficult thing to use. And so we tried to put the frequency buckets into a usable frequencies, common frequencies that you might see. And really what the idea is, you try to find the closest frequency, but you're better off to go, if it's, for example, if it's 4 per minute and you jump from that to 2 per minute and it's only 3 per minute, you go to the more frequent frequency to be more protective, right? So go to the higher frequency to be more protective if it's in between is sort of the rule that we are looking at there. Hopefully that makes sense and answers the question. So it also depends on the height of the person performing the job. Yes, that there are some factors there. We've designed this tool to look at the shorter individual to the taller individual. And what I mean by that, if you look at the visual here, the above shoulder is that limitation there, or that bucket starts at the shoulder height of the shorter individual, right? So if the shorter individual can access an area, we're making them our limiting factor as far as the upper levels. And if we look at on the right side, the taller individual, we're using their knuckle height because then they're going to have to bend if it goes below that. So that's the color coding is attached to those anchors based on the shorter people for the upper limits and the taller people for the lower limits. Hopefully that makes sense. And certainly you'll get my contact information if you have more detailed questions or, I didn't answer your question properly. We can dive into that at another time. And I'm going to keep rolling with this one here. I'll come to some of the questions that are coming here, maybe closer to the end. Okay, so we'll look at another example here. So container access. So this is kind of section 2 of the tool. So we're looking at designing of containers and rack storage, that sort of thing. Okay. So this example here is workers are accessing items frequently from a bin, similar to what you might see at that bottom picture there, with a hand height of 20 to 80 centimeters. So kind of low to mid-range, and then items require a reach, so away from the body of 15 to 70 centimeters away from the body. So that's pretty much, full extension, full reach forward. So is this task optimal design? So we look first. We know that we've kind of color-coded our ideal zones here. So if we can keep what we're handling within those ideal zones at the top as far as like a storage rack, within that 86 to 125.5 centimeter range. And for a bin, we want to keep it nice and close. So 0 to 45 centimeters in that range. That's sort of that close range. And we kind of delineating frequency or frequent as 34 to 66% of the shift. That's a commonly utilized category there. We know that our bin here, we're lifting from 20 to 80 centimeters, so we automatically know we're not kind of in this ideal zone here. We can't always be there. We can't design all of our work to be in that zone. It's not possible, but we know we're kind of in this zone already here. But the more concerning thing is that reach, right? So that 15 to 70 centimeters away from the body. So that's that kind of into this avoid zone, this red zone, because it is beyond 65.5 centimeters, as you see that cutoff there. And hopefully the font is big enough for you guys to see, but you can always reference the tool afterwards as well. So is it optimal? No, it's not. So we've designed it so we have to reach as far as possible into this avoid section or avoid segment away from the body, and we're below kind of our ideal heights there as well. So it's kind of a double whammy from that perspective. So what can we do? What can we do? Can we keep the items between that range? Maybe if we use things like pallet lifters to raise the bin. Maybe there's some stackers we could implement. Maybe even pallet stands or extra pallets could help raise things up so that they're not so low. We may need to have some flip down sides on the bins or hatches to allow us to access things better. So different things as far as kind of packaging goes. Can we reduce the reach? Right, we said that 70 centimeters. Can we bring it closer to the body and hopefully within that 45 centimeter range, using something like tippers, carousels, right? So rotating this bin or reach or pick sticks even, so that we're not doing the reaching, a tool is doing the reaching. Can we move that load closer before we lift? So we have to lift things out of this bin. Can we at least just pull it closer to us before we start that lift, right? Because we're putting our back and shoulders at maximum load if we're reaching in that full extension. And can we just break up those loads? So if we have to lift it, can we break up the loads into smaller and more manageable parts? So again, kind of general control examples, ideas that we kind of put in the tool for you as well. Let's come back to the chat now here. Okay, so I think this one takes me back to the previous example. I'll go back here. Sorry, guys. Okay. So Manisi, sorry for clarification on the figure as an example A21. Does the 21 represent the kilogram value that is acceptable? Yes. Apologize if I didn't make that clear, but yeah, the numbers that you see in here in this chart format, so beside the A, beside the B, that is your maximum acceptable limit or load as far as the weight. So that's your recommended weight limit, okay? Apologize if that wasn't clear there. That is the idea. So the frequency legend tells you, what A, B, C, D, E, F, E means, and then when it's in the chart, we're talking about the kilogram value, the weight limit. Okay. And Colin, this works like a cleaner, more intuitive version of the MyTall tables. Great consideration for human factor. Yeah, exactly. I'm glad you see it that way, Colin. Thank you for that statement. That is the idea and what we're going for, and I'm glad you see it that way as well. And Olivia, no weird questions. What if you work in childcare and the materials are both sentient and sometimes extremely wiggly? Yeah, these, again, we're looking at assumptions, limitations. If we are working with in healthcare where we're actually lifting humans, and they can be irate, they can, be shifting, changing, unbalanced, it can be difficult. So, this is probably not the ideal tool to be using if we're talking about lifting humans. So hopefully that helps. But really, in the same token, if we can minimize any lifting that we're doing as far as handling of those conditions, in farming, you get into other things like that as well, unbalanced loads or livestock or whatever, and we want to minimize that whenever possible for sure. So looking at your hierarchy of controls is the best place to start and eliminating for sure. But yeah, we're really talking about, for the most part with these tools, and any lifting tool for the most part really is not looking at loads that may sporadically shift and change, right? So good question. And we'll move on from our container. Sorry for the clicking here. Okay, So we'll do a carrying exercise now. So workers are carrying a 17 kilogram box of hardware. Okay, so commonly very kind of heavier items, kind of more compact, that sort of thing. It's performed two-handed. The distance of the carry is 8 meters approximately, and the task is performed once to twice per hour. So is this design optimal? So we look at our chart here. So we know it's two-handed, so we're looking at the top of the chart here first. And so we're in that first section, okay? We know we're in this column because it is that 8 meters. So you see at the bottom here, kind of 1 to 3 meters, 4 to 6 meters, 7 to 10 as that distance range. So we're in the 7 to 10 range. And so we're in this column here. And then we look at our frequency once to twice per hour. So we go up to the higher frequency because that twice per hour is going to be more protective if we use that number instead. And so we see that we are in frequency B, which points to 19 kilograms as the limit on that carry. So is it optimal? We're likely okay because that 17 kilograms is below that 19, as long as we know we're using good technique and keeping it close to the body. Now, is it best to limit those carries of 8 meters? For sure, but we know if we do it at this frequency and that sort of thing, then we're likely okay for the most part. So that's an example of a carry for you guys. And just see, Tim, what about large, bulky, light loads? So, you know, these tools and most lifting assessment tools, they don't look at sort of lifting something that may require bringing your arms way out to the side, for example. It's kind of keeping arms close. So a lot of these tools are developed with research related to handling things fairly, you know, as close to the body as you possibly can. So we get into those scenarios where it's bulky, it's unbalanced, it's awkward. You know, probably in most cases, the limits that you see here are going to need to be reduced somewhat if it's unbalanced, bulky, awkward. So that is a good question and a good caveat to note there for sure. And what about pushing and pulling? We'll do an example for pushing and pulling now. So we got workers who are pushing full carts of product for about 35 meters, which is fairly far. The task is performed 1.5 times per minute. So that would be kind of like averaged out through the day. And the forces that were measured, so we need to have our initial force or our starting force. So this is 14 kilograms, and then the rolling force or sustained force of 6 kilograms were measured. The handle height itself is 94 centimeters. So is this task design optimal? So we're in this bucket here, or these columns here, because of that distance. So 35 meters was the distance we determined. So it's beyond sort of that cutoff of 20 meters. It's between 20 and 50. So we go up to the higher number there because that's going to be more protective, right? Once we do that, we look at the frequency. So you can see on the left side, the columns here, the frequencies are outlined there. So we'll go twice per minute because it's 1.5 times per minute. So we go up to the higher frequency. So twice per minute, and we move over and we look at our starting and rolling forces for that frequency. And it's 12 kilograms for that starting or initial force and 5 for the rolling or sustained force. So is it acceptable? The hand height there we know is 94 centimeters, and it is within that kind of hand height range that is optimal. So there's some design components as far as cart design in this tool as well. So 94 centimeters is okay, but it isn't optimal. This design is not great, or this task is not great because it is above, the forces required are above what the recommendations are. So what can we do in this scenario as far as controls? Maybe we can use a mechanical means instead. So can we just use a forklift, a tugger, an AGV, anything to kind of mechanically move, or maybe it's motorized pallet jack instead or something like that. Can we just reduce the force? So maybe all we got to do to get it to the ideal 12 kilograms initial force is, clean up the wheels, perform some maintenance on the wheels, put some grease in there, whatever it is as far as maintaining those wheels better than we have. And we might even get it to that acceptable force limit. Or maybe we just swap out the wheels for a better designed wheel, designed for kind of force reducing casters. And so that might be an option. Maybe we can just reduce the load. So just reduce how much we're putting on that cart, or the frequency itself. Can we reduce that frequency to a more acceptable frequency? And the distance itself as well. Can we bring things closer so that we're not pushing and pulling that 35 meters, which is fairly far. So, and back to our chat here. On the resource page, is there a numbering or other intuitive mechanism for someone to understand the order of considerations to process through the values and get to the recommended force limit? Yeah, there are instructions. It's usually 3 to 4 steps of instructions to walk you through what you need to do. So like an order of operations. Understand totally as I go through this here, it's a little bit difficult to follow along potentially without that resource directly in front of you. And, maybe that would have been a better option to give you that link ahead of time so you could follow along, but you're going to be following that along with my slides, and it could have been even more confusing. So chose not to go that way. But definitely there is an order of operations and instructions in the document itself. The basis of these tables. So that's outlined in the assumptions and limitations section for the tools as well. So it'll tell you where we came up with these limits and what they're based on and what assumptions we made. So you can definitely look at that. Each section may use something different. We rely quite heavily on the Liberty Mutual manual material handling equations, which are equations used for lifting, lowering, pushing, pulling, carrying. So a lot of it's based on that. Force not in newtons. Force can be in newtons, but often it's measured in pounds, force, or kilograms. And so we chose to use kilograms for ease of use there. Great question. And you're throwing a physics formula at me. That's good. I like that. I like that for sure. But it is often measured in kilograms as well. So we use that often. So in summary, this is a tool that is designed by us ergonomists for those with minimal knowledge, ergonomics knowledge, which again is partly why we went with kilograms as opposed to newtons as well. It's a more commonly used unit. And really it's all about being a tool that's simple, easy to understand, kind of give you that easy to understand approach. Give you some visualization of, what's good, what's bad, what's optimal or suboptimal condition based on the work that you either currently have or want to design, and to do it quickly. So, if we give you something simple like this, kind of as a rudimentary, preliminary tool, then it's going to be hopefully more usable and easy to understand. And again, practical, right? We want it to be used for those real practical circumstances. We get into, the healthcare sector and lifting people. It maybe isn't quite as practical, but definitely further conversations to be had from an ergonomic standpoint with those individuals as you wish, and I'll provide my contact information. All right, so another poll for you guys. Now that I've talked at you long enough. Do you think this tool, Ergo Insights, will be able to help you better understand and design manual material handling tasks to prevent MSDs? And your honesty is welcome here. Yes, no, maybe, question mark, or you want to try it before you say yes, which I completely understand. Let you guys finish up answering that one. All right, most people saying yes, so that's fantastic to hear, and that's the idea. We want to give you something that will be able to help you, because as we sort of started off, right, these are complex issues, and it's difficult to know, to answer that question, how much is too much, right? And many of you also saying you want to try it before you commit to answering, which is totally fine. I would probably be the same. And you'll be able to, because we're going to give it to you for free. Next poll question. Would you like to see more resources like this? So looking at potentially doing some more design related resources. kind of an Ergo Insights series that we'd like to continue with. Would that be something you'd be interested in? Excellent. Everybody's saying yes. That's fantastic. Great to hear. Thanks everyone for your answers there. Okay, so having said all that, here's where you can access it. You can go directly to our website at WSPS.ca. You should be able to click that link there if you'd like, and you can type in Ergo Insights and it will pop up in that search bar, or you can simply follow directly to the link. But want to make sure you have our website link there as well in case, because we have so many great resources and information there. But that direct link there, Ergo Insights, will definitely bring you right to that tool that you can use and try it out and see see how it works for you, see how you like it, and definitely open to your feedback with that. And we'll provide this link as well in the follow-up email as well in case you need that for later. Okay, I'll get to questions in just a moment here, but also wanting to just let everybody know something else that we're working on, going along with the theme of getting away from the reactive state into proactive and giving you something that could help as a preliminary standpoint. We have developed a preliminary ergonomics risk assessment tool, and this is a screenshot of what it kind of looks like. And again, designed to be that sort of simple, quick, easy to understand, provide you with a visual and prioritization of risk. And so I won't go into great detail of that, but just letting you know this is something that we have developed and are working on, and you may see more of this coming into the future. And really, we're all about getting people out of that reactive state into proactive. And so that's hopefully what this is designed to do, as kind of a quick method to get you to look at your processes and your work. So what might be some next steps as far as this tool and kind of where we go from here? So take that link, find that Ergo Insights doc, use it in the current jobs that you have to understand, are these a problem? Are these tasks we do an issue? Or when you're designing work, right, as a more proactive space to look at, what does this limit need to be? How can we better design our work? You may look at that preliminary ergonomic risk assessment, as I just brought up, as an option. You may need something more in-depth. So if you have a complex situation where this tool, the Ergo Insights tool, just may not fit for you and you need to go beyond that, you may need something like an industrial ergonomic assessment, which goes into more detail, in-depth from someone like myself or any of our ergos. Maybe you need some design related information where we want to train up some engineers or the people who are responsible for designing work and give them some ergonomic background and ergonomic information as far as designing things better and not letting the risk points trickle down from the design into the human. Try to stop it before it gets to that point, right? Or maybe you want to involve an ergonomist in design reviews, looking at CAD drawings, layouts, all these sorts of things. I sat with a group of 10 engineers a couple of weeks ago doing something like this, and it was really great to look at these CAD drawings of work cells before they were even live with the worker to try to design out some of these potential issues that we see. And so very valuable. Consider integrating ergonomics into change management. So any change that you foresee, or maybe you have your own internal change management processes, maybe it's purchasing, procurement, look for ways to integrate ergonomics at those stages, and you're going to have a bigger win overall. And then again, overall, just looking for opportunities. How can you be more proactive with ergonomics as opposed to that reactive state, which so many companies kind of stay in? And again, which is why we kind of hover at this 30 to 40% or 35% MSDs overall. So just a quick disclaimer that the resource that we're giving you today is that preliminary assessment. It's not an in-depth assessment. Anything that you look at when you're using this tool that deviates from the assumptions that we make or the conditions that we use to develop that resource might require you to do a more in-depth assessment. So just want to make sure that that is clear for everyone. And that is it for me. So we will turn it over to question and answers now. I think I've tried to answer much of this in the chat as it's come through, but I will have a look and see if there's some that I've missed here. So thank you, everyone. Appreciate the love. Right. Okay, so Kim, let me just go back here and see. Okay, Vikas, in automobile industry, baskets which employees push weights more than several hundred pounds, and the initial forces are in the range of 65 to 70 pounds. Is it okay for them to push or need more interventions to do? Oh, so you're asking me to actually assess it for you. I would say I can't do that right now. I would say this is an option where you could look at using the tool. The weight, that really depends on what the force is. You say initial forces range from 65 to 70. That's fairly high, I would say, right off the top of my head. You would want to do a more in-depth assessment on that. You could use the Ergo Insights to see, but I would estimate that's going to be higher than ideal. First glance here, but again, that's without assessing properly, hard to give you a full answer on that. Kim, don't forget office people on the risk assessment tool. Yes, so the preliminary risk assessment tool is for non-office environments. We definitely do lots in the office realm from an ergonomics perspective, but it would be separate from that preliminary tool. We have other tools on our website, office ergonomics checklist that you can use for that. And of course, we can do office assessments as well. And Colin, would that risk assessment tool be formulated and result in an output when you select all variables, high, medium, low risk, or would it be similar to the checklist tables shown today? Oh, so you're talking about the preliminary assessment tool or risk assessment tool, and I'll just kind of go back to it here. Result in an output, you select all variables, or would it be similar to the checklist? Yeah, so there's this tool. I'm not going to go into great detail today on it. We can certainly talk further, Colin, if you're interested in it. Again, you guys will get my contact information, but it's kind of, there's 7 things that kind of drive the tool. So looking at things that might be too low, bending or twisting, too high, and so on. And so these things are looked at for each kind of task. It's a task-based assessment. And then you get a risk point. Each risk point gets its own risk value, and then an overall risk assessment that you'll see. So again, this is not our tool we're focused on today, but certainly we're going to do more as far as introducing that tool in further discussions. Is an electronic tool. It is Excel based. We are right now, it is Excel based, and so it can be done that way. It can be printed out and done on paper. We are looking at eventually, hopefully, making that a web-based or app-based type tool, but that is not confirmed yet. Again, it's fairly new for us right now. Yeah, good for a summer student to do an initial risk assessment. Yeah, we're looking at, I think people would need a little bit of training to do this tool on their own, but that is what we're looking at to provide a tool for clients like yourselves, customers who need this kind of a risk assessment, but just a little bit of training in order to use it first is the ideal. All right, moving along here. Thank you, everyone, saying lots of super useful presentation. Thank you. Excellent. Thank you. Thank you for your comments. So question in relation to lifting task acceptability. If a task resulted in a suboptimal zone or yellow, and the kilogram lifted was greater than 9 kilograms or generally above the recommended weight limit, I think you're saying, would it then veer the task into unacceptable? I'm just trying to grasp your question here. So if the lift is greater than what the recommended weight limit is, then it would be unacceptable by the terms of assuming that we're going with the assumptions and limitations of the tool. But I think you're asking, if the weight is acceptable, but you're in a yellow or a green, like if it's a high weight, but you're in yellow or green, is it actually okay? Well, not necessarily. The yellow green really just showing you what the optimal zones are, and the weight limit is what you want to go by as far as whether it's acceptable or not. How do I determine what the force is? We have some folks pushing barrels. Yeah. So if you don't have a force gauge, so we're talking about pushing and pulling forces. If you don't have a force gauge, it'll be difficult to get those forces. You could estimate it, using the weight, coefficient of friction, and all these sorts of things using a complicated formula. Someone who knows how to do that could work and give you an estimate, but really you need a force gauge to get those push-pull forces. So it can be a little bit more complex than the lifting examples. All right. Yeah, excellent. Somebody saying you want to use it. That's great. Yeah, so again, with the force, difficult to determine the force without a force gauge. Yeah, a fish scale is also another option there that I've seen people use as well. It's fairly cheap, fairly cost effective. It's not going to be likely as accurate a result as a calibrated force gauge, but it might give you a starting place. So that's a good statement there, Tim. And then, yeah, just Tim kind of helping out Sammy. That's fantastic. Love it. Luggage scale, yeah, that could work as well if you have a luggage scale, very similar to a fish scale as a starting place again. But again, those typically aren't calibrated, and so if you're making big decisions based on those things, you may want to be careful. All right. I think that's all the questions I'm seeing coming in here. So I'll hang on the line for a little bit if more questions come through. But I just want to say thank you to everyone for attending and hope this was informative, and I hope you find this tool useful. So thanks everyone for tuning in. Enjoy the rest of your day.